Hello everyone and thank you for joining me. My name is Akir and today we're going to talk about something called recursion in Java. And recursion tends to be very complicated to, to students who learn it for the first time. Well, it is a complicated thing to grasp, but I would recommend anyway, then whenever you start your way with recursion, is to first practice very more easy examples, more easy practices, just for you to know the routine of things, to know uh, to get the concept, to get how the movement is going, and practice again and again. This is what I would recommend. And once you understand the simpler things, just go on and do the more complicated ones. Okay, so right now we are going to begin with something that is very simple, but yet very crucial for you to understand before you jump into more complicated things. Okay, so let's dive in. And I'm using BlueJ, by the way, which is I chose this compiler because it's very simplistic and it's easy to read. It doesn't autocomplete you, but you can choose any compiler that you want. In here, in my main method, I created a two-dimensional array called it m. It's sized 3 by 3, and then I set it up to this number. I assign these numbers to it on the first column. So you see, row 0 and column 0 got 1, row 1 column 0 got 2, row 2 column 0 got 3, and this is what I put here. Of course, the rest of the array is going to be defaulted to initialized with zeros, since this is an integer array, okay? And Java knows how to initialize primitive types by itself, mostly. So therefore, even when you don't put anything, it puts 0 there for you. It's initialized the array to be zeros. Okay, so anyway, I got it ready like that. And what I want to do now is I want to, just for practice sake, basically, take this column and sum it up to actually get the result eventually of how much all this column, what is to get the addition of all this column. So for example, if I run this, you see that it gives me the answer of 6 because it added 1 plus 2 plus 3, okay? So let's see how it works. So this is the first, this is the call that initialized the method call, the recursive method call, and I called it with this array, which in here is called m, and with 0. In here it gets the array, but it calls it a. Okay, the names aren't matter at all. It just means that in this method, it's just going to refer to whatever I passed onto that as a. So I'm pasting m. That's okay. All it needs to know that it's getting a two-dimensional int array. Okay, and also I'm passing an integer of I, and that will serve us to keep track of the location in our array, which is very important when you are dealing with arrays in recursion. You'd have to keep track of them because you don't have loops inside and all sorts that will help you keep track. So this is passing it on as a parameter, and we'll see how to use it in a minute to iterate through the array wherever we want. Okay, so what you do with recursion is you write the final term, the ending case first, basically, in many times, and you kind of think backwards about this. Now, sometimes you don't need how it's going to end, so it's like you don't have that in your mind, but that's okay. You can either add it on later, or maybe you can think about the movement, and then by thinking about the movement, that would give you the end term, the final conditions that will finish the recursive call. So let's see what is the thought process here. So in here we need to scan this one, we need to scan this one, and then we're finishing. We finished. So like many array manipulations that we're doing, we're following the elements inside the array. We actually can terminate this iteration by reaching to the end. So let's say if we have I here, I is 0. In here the I is 1. In here the I is in index 2, at index 2, and in here it terminates as it gets to 3. Now 3 is also the size of the array. Therefore, whenever you write in a loop to iterate through the array, you're writing as long as I, let's say this is how your iterator is called, as long as I is less than array.length. Let's say our array name is m, so as long as I is less than m.length. Why? Because the count starts from 0, so 0, 1, 2, and the length is 3. So that will keep it within the ranges of the array scan. Anyway, let's go on to our recursive call. So this is what we write here, as we want to finish when we get to the end, when I gets to length. And when it happens, it returns 0. But when it's not happening, when it's just calls that making the calls, the false calls, it doesn't happen straight away. So what happens next is it goes to here to call this method again and again and again, every time increasing I by 1. So what I think to do is maybe to bring up some let me bring up some nice pen tool to write the method call on the screen, and yeah, that will be easier to see, I think. Let's see. Okay, how do I do this? Okay, so I'm going to draw this very carefully and simulate the method calls. Okay, so the false call, I is 0. Okay, so that's and we are calling this method, so that's the first call that we have on our stack. So let's write it down. I is 0. Okay, so what happens? We come in through here and we see that this if statement doesn't happen because I is 0 and it's not 3. It's not a.length, which is 3 basically. It measures all that. So it's not that. So we don't do that. What we're going to do is we're going to the second row, but there is a catch here. On the second row, you see this statement is actually assembled from two statements. You have this statement here, and you have this statement here, this method call. Whenever it happens, whenever you see a line like that, and just remember that in Java you're not necessarily have it all on the same line. Okay, it doesn't matter if it's below it or next to it, but the command ends with the semicolon, so pay attention to that. When you have a command that is written like that, it's a combined command with both a method call and something else. First, what it will do, it's going to call the method call. That's what's going to happen first. And what's going to happen next, when it comes back, it's going to continue to do whatever was left, whatever it didn't do before. So let's see. Now, this is the 0 time. Now we are calling the method again, but this time we take I, which is 0, add 1 to it. So we create another method call here. Let's do that. And with I, which is 1. What happens? We are checking this condition, it doesn't happen, and we go here, we see another times that we have a method call, so we go to the method call. And we call it now with I plus 1, so 1 plus 1, because it was 1, so now 1 plus 1, so this is 2. We have another call with 2. And now we go on again, and we have another call with 3. And what happens on this call actually? So we call it with 3. We're going to here, and we check this condition, and it happens this time. So then we come across this word, return 0. We come across this word, we return in 0, but to who? We return 0 to the method call itself. So the method call that called it with 3 was from here. Now we're returning the 3 to the method calls that called it and caused it to be 3. So it's this one. So we can say that 0 is coming back to here. So this method call is going to be replaced with 0. And it also applies with any method that you're calling. Any method that you're calling and it returns you something back, basically the call itself becomes the returned value, okay? So this is the call, and it's got returned with 0. And the 0 goes here, and what happens next? Like I said before, earlier, it tries to complete the other things that is written together with the method call now, because there's no method call anymore. You see it's got 0 now, and it's going to continue and doing the other things. So the other thing is return whatever in I and 0 plus that 0. Okay, so but what is I now? So I just comes back. So whenever it's 3 and it became 0, it got returned. Whenever it got returned, you see this thing. It returned reversely, actually on a reverse directions than the method call. So in here it's 3, it's got to the end, it said return 0, that 0 got returned to here, to the ones that called it before. So in this case it means that I was 2. So I was in position 2, meaning that it has the number 3 in it. Okay, so 0 from this call plus 3, and then where does this 3 comes back to? To here, to the method call that was before it. So 3 plus whatever is in it, which is 2. So this is let's write it down. This is 3 plus 2, which is 5, and then it comes back to this call again. So 5 plus this one, and this one now it's 1, right? So 5 plus 1, 6, and we're returning 6 to here. This is 6, and that's also our first call. Therefore, that if we return from that now, if we once we are finished with this first call, we're just going to return 6 to who? To the first call that was made. So this is also a method call. So we return the 6 to this method call. And that's it. We finished the recursion stages. Therefore, this is 6. Okay, well, I hope that it was that I explained it clearly and you managed to understand. Another tip that I can show you, basically, if you're using BlueJ, it has a very good debugger, and that's like one of the reasons to use BlueJ actually, because like I said at the beginning, it doesn't autocomplete you, it doesn't do many things that that you think about. So basically, but it has a really good debugger. Okay, that's like one thing that it does very nicely. It's a very good study tool, I think. It's, it doesn't autocomplete you, so you have to write everything yourself, but it also has a really good debugging tool. So if we mark those lines that you want to stop, I'll show you. We mark the lines that I want to stop on, and it's enough to just mark these two. Go to the main window, to the project window, right click on the class itself, choose the void main to run, and actually I ran it before, so I'm gonna stop it and see if it's running in the background. No, it's okay. So let's run it. And when you run it, it's going to open a debugging window because you chose it to be, you stopped those lines, so it knows that now it's in a debugging mode. It's not going to run normally. And in the debugging mode, you see what happens with both method calls. So you see we came from main. This is the first call. And this is now the second call with 1. You see you see it live. You can see this is the first call, and I was 0. The second call, I is 1. Next step, we go again. I now is 2. Next step, we go again. I now is 3. And mind you, how it doesn't get after to the second row, because it gets to, basically it returns. Okay, so now it goes to the second, it doesn't go to the second row to run the method again, but now it goes back to the return side of things. So now you see the this is the reason you see the I decreased, and one of the method calls got disappeared because it returned it. And you see another time how it disappears from here. You see the method calls are disappearing. It means that it's returning, like I showed you previously. It's returning and returning. Now it's returning 6 to the main, and it goes to here, and it's going to print it out. So yeah, a very nice tool. Okay, so hope it was informative and you liked it, and if you like it, please subscribe and put a thumbs up or something, that I'll know that you liked it. If not, it's okay to vote it down. Yeah, so I'll see you in the next video. Thank you for watching.